In this lesson, you will learn about Docker. I promise you that by the end of this video, you will have a clear understanding of what Docker is, the problems it solves, and how it differs from virtual machines. But to fully understand Docker and why it was created, it's important to know how traditional machines work and problems that come up when deploying applications on them. So let's start by understanding the architecture of a traditional machine. On a traditional machine, you have hardware that includes a CPU, RAM, storage, and a lot of other components. On this hardware, you then install an operating system of your choice, such as Windows, Linux, or macOS. After that, you install the necessary libraries and dependencies. For example, if you want to run a Java application, you need to have JDK installed on your machine. And finally, you run your application, such as a Java application, an Nginx server, or a database like MySQL. Now let's look at the problems associated with deploying applications on a traditional machine. Let me illustrate it with a story that many of us can relate to. Imagine you are a developer working on a project that uses Node.js and MongoDB. You have been working hard on a new feature and it's finally ready for testing. You send it to your colleague Adam, who is a QA engineer at the same company. Adam runs the code on his machine, but it doesn't work. He comes back to inform you that the code you shipped is not working on his machine. However, you are confident that the code is fine. But just to be sure, you run it on your machine one more time and yeah, it works flawlessly. There is nothing wrong with the code. So you go back to Adam and tell him, hey, the code is working fine on my machine. Why is it not working on your machine? Now, why did that happen? Why is it that the same code works on one machine but fails to run on the other? Let's try to look into the possible reasons. First, incorrect installation of dependencies. Adam may not have installed the dependencies correctly. In this case, he might not have installed Node.js and MongoDB on his machine. Let's talk about another common issue that can cause problems: version mismatch of the dependencies. Adam may have installed the wrong versions of the dependencies. For example, let's say the project requires Node.js version 20 and MongoDB version 8, but Adam could have installed Node.js 16 and MongoDB 5 on his machine. Another common reason could be conflicting software. Adam's machine might have numerous other software, libraries, and dependencies that conflict with those required for this project. Last but not least, the problem could also arise due to an incompatible operating system. Adam might be using a different operating system that is incompatible with the required libraries and dependencies for this project. Alright, now let's talk about the disaster. What if Adam had the same operating system as you and also had correct set of dependencies installed on his machine? What if the code ran flawlessly on both your machine and Adam's machine? What would have happened? Adam would have sent it for production deployment, right? But what's the guarantee that it would work on the production server? What if the production server is using a different operating system than you and Adam and also has a wrong version of Node.js and MongoDB installed? There is no guarantee unless the production machine runs the same operating system and has the same set of dependencies and libraries correctly installed. And this is one of the biggest pitfalls of deploying software on a traditional machine. So, what's the solution? One solution is to bundle everything together. And I mean everything, including the operating system, binaries, libraries, and dependencies. And then use the same bundle across all your environments: development, QA, and production. And this is precisely what virtual machines do. With virtual machines, you can bundle everything together, create an image of the bundle, and then share it across all your environments. Think of an image as a frozen state of the virtual machine that can be easily duplicated and deployed onto the other systems. Images are used to create new instances of VMs, enabling consistent and reproducible deployments across different environments. But how do virtual machines work? Imagine you have a physical machine with an operating system already installed on it. Now, on top of that, you can install a special piece of software called a hypervisor. Popular options of hypervisors include VMware and VirtualBox. This hypervisor does a cool trick. It creates and runs virtual machines. Virtual in the sense that it's not a physical machine, but a software-based emulation of one. Think of virtual machine as another computer inside your real computer. The hypervisor lets your main computer act like a host, sharing its resources like CPU, memory, and storage with these virtual computers. But remember that each virtual machine has its own operating system. This is known as the guest operating system because it runs on top of the host operating system. Now you can install the required libraries and dependencies on this guest operating system and finally run your application, such as a Java application, an Nginx server, or a database like MySQL. The beauty of this virtual machine is that it can be bundled and shared. This bundle in the context of virtual machine is called an image, or ISO image to be more precise. This image can be shared with anyone, anywhere, and can be used to create copies of the VM instances. Let's go back to the story involving you and Adam. This time, the DevOps team created a virtual machine using VMware. This virtual machine has Node.js 20 and MongoDB 8 already installed on it. It also has all the other required libraries and dependencies. They bundled this VM and created an image from it, which they shared with you and Adam. The same image will also be used in production. Now you and Adam have the same image. You both can create a virtual machine from this image and run your code. This time when you work on a feature and send it to Adam for QA, it is guaranteed that if the code worked on your virtual machine, it will also work on Adam's virtual machine. So with virtual machines in place, are things all good now? Although hypervisors and virtual machines offer numerous advantages, there are also some disadvantages to consider. First is performance overhead. Running a full-fledged operating system inside a virtual machine requires additional processing overhead. This can lead to reduced performance compared to running the same operating system directly on the host hardware. Another concern is with resource limitations. Each virtual machine requires a significant portion of the host system resources such as CPU, memory, and storage. This can limit the number of virtual machines that can be run simultaneously on a given hardware. Next is complexity. The setup and management of virtual machines can be more complex than managing physical machines. It may require specialized knowledge and tools. Finally, there are licensing costs. Each virtual machine needs a full-fledged operating system and may require a separate license. Imagine running thousands of VMs, each having its own license. This drastically increases the overall cost of running an application. Is there a better solution? Yes. Welcome to the world of containers. With containers, we can overcome these issues. But what are containers? You can think of containers as a more efficient alternative to virtual machines with some key differences. First, instead of a hypervisor, you have something called a container runtime. Docker and Containerd are two popular container runtimes out there. Second, like virtual machines, they ensure isolation, but without the overhead of running a full-fledged operating system. This leads to a better performance and resource utilization. Third, containers are more lightweight than virtual machines. They share the host operating system kernel, which results in lower overhead and better resource utilization. Fourth, containers can be deployed and started quickly. They do not require a time-consuming process of booting up a complete virtual machine, allowing for a faster deployment and startup time. Okay, now you know what containers are. What is Docker then? Think of Docker as a super handy toolbox for containers. It helps you deploy and manage containers. It allows you to create container images that can be shared with anyone. These Docker images can then be used to create containers. You can create multiple copies of container using a given Docker image. These containers run consistently on any machine that has Docker installed on it. Docker also allows you to define your infrastructure as code using Docker files, compose files, and other configuration files. This means that you can define your entire infrastructure stack, including your servers, databases, and other components using code. This has a number of advantages. First, It allows you to define and maintain your infrastructure in a repeatable and automated way, which can save time and reduce errors. Second, it allows you to version control your infrastructure code, which makes it easier to track changes over time and roll back to previous versions if needed. Finally, it allows you to easily move your infrastructure stack between different environments, such as development, testing, and production, with confidence that it will behave consistently. Now, let's talk about the compatibility of Docker with different operating systems. In the beginning, Docker was all about Linux. It had a close bond with Linux. For example, you could not run a Linux-based container on a Windows machine because Linux-based containers cannot use Windows OS kernel. But Docker had a grand vision. They wanted to spread the container magic to Windows and Mac users. That's where Docker Desktop stepped in. It functions as an intelligent mediator, introducing a portion of Linux functionality to both Windows and Mac environments. This unique component, referred to as a lightweight Linux kernel, serves as an intermediary, facilitating the seamless operation of containers across these distinct systems. With Docker Desktop, it's not just about Linux anymore. Windows and Mac users also get to share the container's goodness. It's like a universal language that these systems understand, making containers accessible and practical for everyone. Let's recap what we have covered in this lesson. Deployments on traditional machines may have inconsistent behavior. Virtual machine solves the issue of inconsistent behavior but has many disadvantages including performance overhead, resource limitations, complexity, and licensing costs. Docker offers a better solution. It solves the problem of inconsistent application behavior across different machines by providing a way to package applications and their dependencies into portable, self-contained containers that can run consistently on any machine that has Docker installed in it. Alright, that's all for today. I'll see you in the next lesson. In the previous lesson, we discussed Docker. In this video, we'll deep dive into the nuts and bolts of how Docker actually works behind the scenes. You will learn about Docker architecture and its components. Docker uses a client-server architecture. Think of the Docker client as your control center. It's what you use to instruct Docker what you want to do, like create, start, or stop containers. You talk to it directly. The Docker client talks to the Docker daemon, which is the server part. When you give a command to the client, the daemon springs into action, doing all the heavy lifting of building, running, and distributing your Docker containers. These two components, the Docker client and the Docker daemon, communicate using a REST API. This API functions as their communication bridge. When you send a request from the Docker client, it travels via this API to the Docker daemon, which then processes it and sends back the response. For example, when you execute the command docker run with the required parameters, the client takes this request and sends it to the daemon. The daemon interprets what the command is supposed to do and performs the necessary actions. In this case, the daemon will run a container as per the provided parameters. The Docker client and daemon can run on the same system, or you can also connect a Docker client to a remote Docker daemon. In most cases, you will have the Docker client and daemon installed on the same system. But in production, you may want to keep the Docker client and daemon on separate machines to avoid any extra load on the server running your containers. Now let's talk about Docker images and containers in more detail. Think of an image as a snapshot or a blueprint of an application and its dependencies, similar to an image in a virtual machine. It's like a template that contains everything needed to run your application, including the code, libraries, dependencies, configuration files, and environment variables. Let's look at a Node.js application. To start, you pick a light operating system, but just a quick reminder, with Docker, you don't need a full-fledged operating system because the container shares the host's operating system kernel. After that, you bring in Node.js runtime and NPM, which is the Node.js package manager. And then your apps code, configuration files, and environment variables. And finally, add the instructions on how to run your app. Once you have got everything set up, you build a package that can be shared with others. This package is what's called a Docker image. Remember that these images are read-only, which means you cannot change anything inside them once they are created. They are designed to be consistent and portable across different environments. Once you have the Docker image ready, you can use it to run containers. Imagine a container as a running instance of your application based on a given Docker image. Let me reiterate, an image is a read-only template with instructions for creating a container, while a container is a runnable instance of an image. It's like using a recipe to cook a dish. The image is the recipe and the container is the cooked meal. But how does Docker know what to include in an image? Well, Docker uses a special file called a Docker file to create your image just the way you want it. A Docker file, like a recipe, is a step-by-step instruction manual for creating a Docker image. It's a plain text file that contains a series of commands and settings that define how to construct a container image. Each line in a Docker file represents a specific action, like installing software, copying files, or configuration settings. When you build a Docker image using a Docker file, Docker reads and executes these instructions sequentially to create a consistent and reproducible image. Now let's talk about the Docker registry and repository. When you run the docker build command on your host machine to build a Docker image from a Docker file, Docker stores the resulting image on the host machine where you executed the command. But what if you wish to securely store an image and have the ability to share it with others? This is where Docker registry comes into play. The Docker registry acts as a centralized location where you can store images and make them accessible to both your team members and the public. To put it simply, think of the registry as a storage account for holding your images, while the repository within that storage account acts as a folder to neatly organize these images. Docker Hub is one of the most popular and widely used public Docker registries. It hosts a rich variety of ready-to-use Docker images customized for popular applications like MySQL, Nginx, Node.js, and others. That's all for the theory. In the next lesson, we'll get hands-on. We'll install Docker and learn how to create and manage Docker containers. Hey everyone, welcome back to another video. In this video, I'll show you how you can install Docker on a given operating system. Installing Docker is actually pretty easy. All you have to do is visit the official Docker documentation and follow these steps for your operating system. Open any browser on your computer and search install Docker. Click on the first result. It will take you to the official documentation on how to install Docker. Here you will see a list of operating systems where you can install Docker, including Ubuntu, Debian, RHEL, Fedora, and many others. But if you notice, all of these are Linux based operating systems, right? And you do not see Windows and macOS in this list. This is because if you read this sentence carefully, you will understand that you have two ways to install Docker. The first option is to install Docker using Docker Engine, which is available only for Linux. And that's why you see only Linux based operating systems here. But the other option is to install Docker using Docker Desktop, which is available for Windows, macOS, and Linux. So if I collapse this and expand Docker Desktop and expand install, you will see you have Mac, Windows, and Linux there. Now, why is it that the Docker is available to Windows and macOS only via Docker Desktop? This is because you know that to run Docker you need a Linux kernel, right? But Windows and macOS do not have Linux kernel. So what happens is Docker Desktop provides Windows and macOS with a lightweight Linux kernel, and that way you can install and run Docker on Windows and macOS. And that's why you can install Docker only using Docker Desktop on Windows and Mac. Now, when you install Docker using Docker Engine, this thing, you get the Docker CLI and Docker daemon, which are the core components of Docker. But when you install Docker using Docker Desktop, You of course get the Docker engine that has Docker CLI and Docker daemon, but you also get a graphical user interface that you can use to interact with Docker images, volumes, containers in a user-friendly manner. So that is one advantage you have with Docker Desktop. But I would recommend using command line as much as possible, because in real world that's what you will be using, right? Okay, so in this video I'll show you how you can install Docker on Ubuntu and macOS, of course. So first let's start with installing Docker on Ubuntu. So what I have done is, because I'm using a macOS operating system, so what I have done is I have launched an Ubuntu based EC2 instance. So this is my Ubuntu server. So let me connect to this Ubuntu server. So I'll grab the SSH command, come back to my terminal and paste this SSH command. Okay, I'm connected to my Ubuntu server. Let me clear the screen. And now to install Docker, all we have to do is come back to Docker engine, under install, click on Ubuntu and scroll down to this section that says install using the apt repository. Now, before you can install Docker engine for the first time on a new host machine, you need to have the Docker repository set up, and then only you can install and update Docker from the repository. So let's set up the Docker's apt repository first. So let me grab these commands and come back to my terminal and paste these commands. So what this command is going to do is it will set up my Docker's apt repository. So let me run this command. Yeah, done. Okay. Now the next step is to install the Docker itself. So once you have the Docker repository set up, you can install Docker. Now either you can install the latest version of Docker, or if you want to install a specific version of Docker, you can follow these instructions. So if you want to use a specific version, this command will list all the versions that are available. Then you choose the version that you want to install. You can set this string and then run this command. In this case, I'm going to just install the latest version of Docker. So I'll grab this command, come back to terminal, clear the screen and paste this command. So what this command will do is it will install Docker engine on your Ubuntu server. So let me run this command. It says, do you want to continue? Yes. Now it will take a couple of seconds and then it should be done. Alright, Docker is installed. Let's verify. So let me clear the screen, run the command docker -- version, and it will list the Docker version that is installed. In this case, the Docker version that was installed is 27.3.1. Now let's verify if we can run our Docker container. So let me run the command sudo docker run hello world. So it's pulling the image and it actually ran the container. It says hello from Docker. So this verifies that we have Docker installed on our Ubuntu server. Next, let's see how you can install Docker on Mac. Installing Docker on Mac is actually very simple. Now you know that the only way to install Docker on Mac is using Docker Desktop. So I'll expand Docker Desktop, go under install, click on Mac. Now here you have to download the installer first. Here you will see you have two options. The first option is to download Docker Desktop for Mac that has Apple Silicon chip, and another option is for Docker Desktop for Mac with Intel chip. So let me verify what kind of chip I have. So I'll click on this Mac, and here I'll see chip is Apple M2. This means I'm using Apple Silicon. If you see something other than Apple chip here under about this Mac, if you see Intel or something here, then you have to download this one. So let me download this installer. It will take a couple of minutes, so I'll wait. Alright, the download is complete. Let me go back to my downloads, and here you will see I have the .dmg file. So to install, all I have to do is double click on this and it will open the installer. Now I just have to drag and drop this to applications folder, and that's it. This will install Docker. So it says copying Docker to applications. That's all. It's very simple. Nothing much to do. Now let me open Docker. So I'll go to applications and here I have Docker. So double click on Docker and it is going to launch the Docker application for you. Yes, I want to open. So as I said, with Docker Desktop, you also get a graphical user interface. And this is the graphical user interface that you have. Here you can manage your containers, images, volumes, and whatnot. So what I'm going to do is, I'm also going to check using command line. So let me exit from the server, and this is my Mac terminal, the native Mac terminal. So I'll see if I have Docker installed on this machine. So I'll run the command docker version. You see Docker is running on my Mac OS. The version installed is 27.2.0. Here also let me run a hello world container and see if everything works fine. So I'll say docker run hello world. So it says unable to find the image locally. It will try to pull it from the default repository, which is Docker Hub in this case. So it will start pulling the image and then run a container from that. So container ran and it says hello from Docker. And yeah, that's it. We have verified that Docker is running on Mac. Let me show you how you can install Docker on Windows, right? So under Docker Desktop, under install, click on Windows, and all you have to do is download the installer for your architecture that you're using, and then just double click and go next, and that's it. It's extremely easy. Yeah, that's it. I'll see you in the next video. Thank you. Hi, welcome back. In this lesson, I'll show you how you can run a Docker container from a public image hosted on Docker Hub. In the next lesson, I'll show you how you can build your own image from scratch and run a container from that. But for now, we are going to use a publicly available image to run a container. Now, Docker Hub, as we discussed earlier, is one of the public registries you can use to download the official images for many popular services such as Nginx, MySQL, Java, Python, and many more. These official images are created either by the companies that develop these services or by the Docker community. But please note that Docker Hub hosts not only the official images, but also an extensive collection of public images contributed by developers like you and me. So if you have an application that you want to share with people, you can simply create an image for that application and push it to Docker Hub and make it public so that anyone can download the image and run your application inside a container. Now, before you can run a container from an image hosted on Docker Hub, you first need to download the image on your local machine where you wish to run the container. Let's say you want to run an Nginx container. So first, we need to download the Nginx image from Docker Hub. So let's go to Docker Hub. You can visit hub.docker.com to go to Docker Hub and then locate the image you want to run a container from. So here I can search the image I'm looking for. In my case, I'm looking for Nginx image. So I'll search Nginx. I'll also enable this filter that says Docker official image. Make sure you use only official images for production at least to avoid any security problems, because non-official images may have security vulnerabilities and might not be suitable for production. So in my case, this is the official image I'm looking for. You can also see a badge near this image that says Docker official image. So this is the image I'm looking for. I'll click on this image and I'll land on the overview page of this image. Here you can see all the details about this image, like who is the maintainer of this image, where can you get the help regarding this image, what are the supported tags, and a brief description about this application or this image. So as you already know, Nginx is an open source reverse proxy server. So that's what it's written over here. And then you can also see a simple command on how to use this image to run a container. So here you have a sample docker run command, and then you can see you have the environment variables that are supported by this image. All right, now let's talk about the tags, which is one of the most important things about an image. So tags are nothing but different versions of an application. Softwares evolved, right? and you will have multiple versions of the software available. So each tag usually represents a specific version of this application. Okay, so in this case, if you see the tag 1.27, it may refer to Nginx version 1.27. Also, each image has a specific tag called latest, which usually refers to the most recent version of the image. Alright, now let's go ahead and download the image. To download the image, you can use docker pull command. So the syntax is docker pull name of the repository and optionally the tag of the image that you want to download. So if you do not provide the tag, it will download the latest image, the image with latest tag. Okay, so let's go ahead and download this image. But before that, make sure Docker is running. In my case, I can see Docker is running. So let me open the terminal and run the command docker pull nginx. Here I can provide the tag of the image that I want to download, like docker pull nginx 1.25 or 1.27 or whatever tag you want to download. Okay, but before that, let me list out the images that are present on this machine so that we can verify if the image was downloaded or not. So if I run the command docker images, it's going to list all the images that are present on my machine. Currently you can see that I do not have any images present on this machine. Let's go ahead and download the image now. So I run the command docker pull nginx. Now here I'm not providing any tag, so it's going to download the latest tag. Let me hit enter, and here you can see it says using default tag latest, because I have not provided any tag over here. And it started downloading all the layers of this image, and finally the image is downloaded. You can see the status, downloaded newer image for Nginx latest. Now let's verify if the image was actually downloaded. You can run the command docker images to list all the images, and here you will see you have the Nginx image that we just downloaded. So you can see the repository is Nginx, the tag is latest, and each image gets a unique ID. So that's what this ID is about. And then when was this image created? In this case, it was created 5 weeks ago. Now this created is when it was pushed to the Docker Hub. Okay, so that's what this created shows. And then you have size of the image. Usually it will be in MB, but if it's a heavy image, it can go in GBs as well. Alright, now that image is downloaded, let's go ahead and run a container from this image. So let me clear this screen first. Now to run a container from an image, you can use the docker run command. So the syntax is docker run and then the image, let me say image repository or image name. Now this must be present on your local machine. If it's not present, it will automatically pull from the default registry, which is Docker Hub. But in my case, Nginx, we have already downloaded Nginx image. So it will not, it will see the image is already present on local machine and not download from Docker Hub. And then here, the tag of the image. Okay, and then you have additional parameters over here, but let's not discuss them now. We'll discuss about them later in the course. So here in my case, the repository or image name is Nginx and then tag is latest. Now if I do not provide tag, by default it will be latest. So let me run this command and you will see the container is running. You can see logs from this container. And you can notice that the container is running in the foreground, like the terminal is blocked. You can see the cursor over here. I cannot run any other commands here. Now let's list the running containers. So because this terminal is blocked, I cannot use this terminal. Let me open one new terminal. So this is the new terminal that I have opened on the right side. And here to list all the running containers, you can run the command docker ps. Let me enlarge this terminal, and here you can see I have this container ID, the image from which this container was launched, the entry point command, and then when was this created? About a minute ago, because I just launched it. And then what is the status? it has been up about a minute. And then ports, what are the ports this container is listening on. And then if you do not provide a name to your container, it will automatically assign a random name for you. So in this case, this is the name it assigned. Now here you see port 80 because Nginx usually listens on port 80. Now let's go to the first terminal. So I'll come here, let me enlarge this terminal, and to exit out of this terminal or to exit out of this container, I'll just press Ctrl C. Once I press Ctrl C, it will send a kill command to the container and the container will be terminated. Now if I go back to another terminal and run the docker ps command, docker ps, you will see I do not have any running containers over here. Now if I run the command docker ps -a, so -a basically tells this docker to list all the containers either running or dead or stopped. Okay, so let me run this command and you will see I have this container which is in exited state because I pressed Ctrl C and it terminated our container. Now docker ps, you can also run a command docker ps -all. So -a is just a shortcut, but this is the actual command docker ps -all to list all the containers either running or stopped or exited. Also, now let's say I just want to list the container IDs and do not print out all the other details, then you can provide a parameter called -q, which means quiet, or you can also use -quiet. See, it's just going to print out the container ID and not the other details. Alright, let me clear the screen and go back to the first terminal. Let me clear the screen here as well. Alright, next let's see how you can run the container in detached mode so that it runs in the background and the terminal is free to run other commands. To run a container in the detached mode, you can use -d or --. So you can use -d or -detach parameter or argument or flag. Okay, so let's say so let me just kill the terminal container first that we already have. So I'll kill this container. So I'll just say docker remove and the container ID, or I can also provide the container name, this one, either ways. So if I run this command, it will print the container ID that was deleted or terminated. Now if I list docker ps -a, you will see I do not have any running or stopped container. I'll clear the screen. Let's see how you can run the same container in detached mode. So I'll run the command docker run name of the image tag, which is latest if I do not provide, so I don't want to provide the tag here, and then -d. Now -d should come before the name of the image. So docker run in detached mode Nginx container from Nginx image. If I run this command, you will see the container is running and it just printed the container ID that was created. So if I run the command docker ps to list the running containers, you can see this is the container ID, which is basically this. Now let me show you how you can provide a desired name for container. So here you can see it just provided or added a random name to my container. I do not want that. So let me kill this container first, or stop or remove this container. Not stop, remove. So docker remove and then the container ID. It says cannot remove container because the container is in running state. So let me stop the container first. So to stop a container, you can run the command docker stop and then container ID. Okay, the container is stopped. You can see the status of the container. It says exited. Now I can safely remove this container. So docker rm and then container ID. The container is removed. If I run the command docker ps -a now, you won't see any container running. Okay, so let's see how you can run a container with a desired name. So I'll run the command docker run in detached mode name of the container. To provide a name of the container, you can use --name and then whatever you want. So let's say my nginx container, and then the name of the image from which I want to run the container. Here you can provide nginx latest, but latest is default, so I'm not going to provide the tag here. The container is created and this is the ID of the container. Now if I run the command docker ps-a to list all the containers, you will see this is the container that I just ran. 6058, 6058 and up to 490 created 10 seconds ago. And here you can see this time the name is my nginx container and this is the name I had provided. Moving on, let's see how you can execute a command inside a running container. The docker exec command, docker exec, okay, which means docker execute. So this command lets you execute a command inside a running container. The command runs in the default directory of the container. We'll talk about the default directory when we build our own Docker image later. So the syntax is, if you want to run a command inside a container, you can use the docker execute command, docker execute, and then the container name. So here I can provide container name or container ID. So let's use container ID. Okay. And then the command you want to execute. So let's say I want to execute the command ls. So this is the command that was executed inside the container in the home working directory of the container. This will run the command without starting a shell session inside the container. If you want to start a shell session inside the container and work with it interactively, you can use the command interactively. So in that case, you can run the command docker exec -it. So -it flag means interactive terminal. So it's actually going to open a terminal inside your container. Now the ID of the container. Sorry, let me clear the screen. Let me get the ID of the container first. This is the ID of the container. Now here I can run the command docker execute interactively the container ID and then sh. sh means I want to open a shell session inside the container in the interactive mode. So if I execute this command, here you see it opened a terminal. This terminal is inside the container. Now here if I run the command ls, you can see all the directories and files in this directory. So the current directory is pwd. The current directory is root. So in the root directory, you have these folders and files present. Now to exit out of this terminal, which is inside this container, I can run the command exit. So I'm out of this container now. Now if your container supports bash, which is an advanced version of shell, you can also use that. So if I run this command docker exec -it container ID, this is the container ID, and then instead of sh I can use bash. So you see bash. Now bash is an advanced version of sh. It has more features like autocomplete, history, that kind of features. And here you can see the difference. When I started an interactive terminal with just sh, it just gave me a basic terminal, but here it's showing you the home directory or the current working directory, which is root here. So that's what it is. Here you can run all the commands that you want. Okay, let me exit out of this container, and also I'll clear the screen. I want to show you one more thing. So let me list out the containers and let's start a shell session inside this container. So I'll run the command docker execute interactively container ID, and then I want to open a bash session here. Now since it is a nginx server, I know the service is running on port 80. So if I run the command curl localhost, it's going to serve the basic nginx page. You see it says thank you for using nginx. All right, I'll exit from this container and I'll clear the screen. Now let's clean up. So first I'm going to delete the container. So let me list the running containers, or let me list all the containers. So I can run docker ps -all or docker ps-a for short. So I have only one image which is in running state. If I have to remove this container, first I need to stop this container. To stop the container, I can run the command docker stop and then the container ID or container name. So let's say this time I'll use container name, my nginx container. It will stop the container. Now you can see the status. I'll run the command docker ps-a. Here you can see this container is in my nginx container is in exited state. Now that the container is in stopped state, I can remove this container. So to remove the container, I can run the command docker rm and then the container ID or container name. So let me use container ID. You can also use container name. It's up to you, whatever is preferable. So the container is removed and the ID of the container that was removed is printed. To verify, I can run the command docker ps-a. You can see I do not have any container running or stopped. Let me clear the screen. Now I want to discuss one more thing. How do you access the application that is running inside the container from outside? Docker runs the containers in a separate network that is different than your local host network, and therefore you cannot access the application running inside the container from the host machine. So if you try to access localhost 80 in your browser, it won't work. Let me show you. So let me run the container again, docker run -d. I'll give a name to this container. I'll say my nginx container, and then the image from which I want to run the container. So it's going to run the container. I can verify docker ps-a and then the container is running. Now if I run the command curl localhost 80, it won't work, right? Because this localhost doesn't know that it has to run this command within this container or inside this container. It's just going to run this command on my host machine, and there is nothing running on my host machine on port 80, and that's why you see fail to connect to localhost port 80. So how do you access this application which is running inside this container from your local host or from your host machine where the container is running? There is a way. Docker has a feature called port mapping, which allows you to map a container port to a port on your host machine where the container is running, and then you can use the host port to access the application running inside the container. So let's rerun the container. So first let me remove this container. So I'll say docker stop and then the container ID, which is this. Now that the container is stopped, I can remove this container. Alright, the container is removed. We can verify by running this command. Now let me rerun the container with port mapping so that we can access the application inside the container from host machine. So let me clear the screen and I'll rerun the container. Docker run in detached mode. I'll also provide a name to this container, my nginx container, and then here I'll provide the port mapping. To provide the port mapping, you can use the flag -p. Now here the first port will be the port on my host machine. This port is the port on host machine where I want to expose the container. Now the next port will be the actual port of the container where application is running. We know that in our nginx container, the port 80 is exposed and that's where application is running. So this is the port where the container is listening on, and this is the port on host machine where we want to forward this port. Here this can be any port. It can actually be 80 if it is free on your host machine. But in my case, let me keep it 8080 to distinguish which is host and which is a container port. Alright, and then finally the image from which we want to run the container. So in my case it is nginx. Here the container is running. You can run the command docker ps-a to list all the containers, and you can see this is the container. Up for 6 seconds, and then here under ports you will see that port 80 of the container is forwarded or mapped to port 8080 on host machine. So now this is my host machine. This terminal is host machine, right? So if I run the command curl localhost and port 8080, because that's where I mapped my application to, right? So if I run curl localhost 8080, it's going to show me or display the default Nginx page. Now I can also open a browser, open a tab, and then here search localhost 8080, and you can see the Nginx page that is beautifully rendered because it's an HTML page, right? It's an HTML page, so browser is going to render this beautifully. Alright, so in this lesson you learned how to run a container from a public image hosted on Docker Hub. Now let's clean up. So first I'll remove all the containers that are running. So first let me list all the Docker containers. So docker ps -- all or -a. So I have only one running container here. So let me stop this container first. Docker stop and then the container ID, or I can also put the container name. So the container is stopped, and then I'll say docker remove the container and then the container name. The container is removed. If you list all the containers now, you won't see any containers running or stopped. Next, let's remove all the images, because images take up space on your host machine, right? So let's clear up that as well if you do not need. So first let's list all the images. Docker images. So I have only one image. So let me remove this image. To remove the image, you can run the command rmi. It means remove image, and then the name of the image, and then tag. If you do not provide tag, it's going to take latest by default. So if I run this command, it says untag this image, and then finally all the layers were deleted. Now if I run the command docker images to list all the images on my host machine, you will see I do not have any image. I forgot to show you one more thing. Let's say you have a running container. Now how do you view the logs from that container? So let's say I have a container. Let me launch a container first because we cleaned up everything. So I'll run a container from Nginx image. So the command is docker run. I'll run this container in detached mode, and I'll also provide a name for this container. So I'll say the name of the container is my Nginx container, and then the image. So I want to run a container from Nginx image. Now here I do not have an Nginx image locally, right? Because I cleaned up everything. So what Docker will do is it will see that the Nginx image is not present locally, and it will try to fetch this image from the default registry, which in this case is Docker Hub. So let me execute this command, and you can see it says unable to find image Nginx latest tag, because I have not provided any tag here. So it will consider the tag to be latest. So it didn't find this image locally, and that's why it's pulling from the default registry, which is Docker Hub. Now the image is downloaded. You can see the image will be downloaded, and also a container will be running. If I run the command docker ps, you can see this is the container that is running. Then the container ID is F20 and ends with 41D. Here you can see F20 and then here up until this point. So this is the image ID that was printed. So what this command did is it pulled this image from Docker Hub, and then it ran a container from that image. Alright, now let's see how you can view the logs from this container. To view the logs from this container, you can run this command docker logs and then the container ID or the name of the container. So let's say we'll provide container ID. Here you can see the logs from this container. Now this is just all the logs from that container. Now what if we want to tail the logs? Tail the logs means whatever new logs come, we should be able to see that log. So let me clear the screen. Now to tail the logs, you can run this command docker logs -f. This flag -f basically tells Docker to tail the logs in follow-up mode. So I'll provide the container ID from which I want to view the logs. Now if I run this command, you can see the terminal has not exited, but it's still running. It's in foreground. Now whatever operations I do, it will generate some log, and then you will be able to see that log here. So let me open another terminal, and then here I'll run a command in that container to generate some log. So I'll run this command docker exec -it. So basically I'm first opening a terminal inside that container. So this is the container ID, and then I'll open a bash session and I'll run this command. Now I'm inside the container. Now I'll try to access the Nginx application. Now I know that Nginx is running on port 80. So I'll run this command curl localhost. And if I run this command, notice that here you will be able to see the logs that was generated as a result of running this command. So if I hit enter, you can see this is the log that was generated. Now let me give some space here so that you can see a fresh result again. So let me run this command again, curl localhost. You can see a new log was generated. Let me again give some space for clarity, and if I run the command again, curl localhost, it will generate the log, and you will be able to see this log in the follow-up mode that we have started here. So if I run this command curl localhost, you can see the logs. Now let me exit out of this terminal and from here as well. Alright, that's it. Now let me clear up all the containers and images. To clear the containers, first we have to stop this container. So to stop the container, you can run the command docker stop and then the container ID. Now that the container is stopped, we can safely remove this using docker rm command. And now finally, let's also remove the images. So let's list the images first, and then finally remove image using docker rmi command, and then providing the name of the image. Alright, the image is untagged and safely removed. Now if you list all the containers, I do not have any container running, and I also don't have any images on my local machine. Alright, that's all for this lesson. In the next lesson, I'll show you how you can build your own image and run a container from that. Thank you. In this lesson, you will learn how to create a Docker image from scratch based on your requirements. In this video, I'll show you how you can create a customized version of Nginx image and then run a container from that image. In the next video, I'll show you how to create a Docker image for your Node.js and Express application. So let's start with creating a customized Nginx image. But before that, let me show you how Nginx serves the default HTML page when you hit localhost on port 80. So let's open a terminal and create an Nginx container from the public Nginx image. So I'll run the command docker run. I'll run the container in detached mode and then the name of the image, which is Nginx. I'll hit enter. Now I do not have this Nginx image present locally because I cleaned up everything. So it's pulling the image from Docker Hub and then finally it's running a container. So this is the image that was downloaded, and finally we have a container running with this ID. Let's verify. I'll run the command docker ps to list all the running containers. And here you can see we have this container 7f and ends with 77. This is the ID. Now let's start a terminal inside this container. So let me grab this container ID and then I'll run the command docker exec -it because I want to open a terminal interactively, and then finally container ID, and then I want to open a bash session. Alright, we are inside the container. Let me clear the screen. Now when you hit localhost on port 80, you can see the default HTML page that Nginx serves. This is the HTML page. But how does that work? Let's see. Let me clear the screen first. So Nginx configuration is stored at etc nginx directory. So let me go to etc nginx, and if I list all the files and folders in this directory, you can see we have a file called nginx.conf. This is the entry point configuration for Nginx. So let's view the content of nginx.conf. So I'll run the command cat nginx.conf. Now if you look closely, you will see that it loads configuration from nested configuration files, which is located under etc nginx conf.d. So we are already inside etc nginx. Let's list all the folders here. You will see we have a folder called conf.d, and if I go inside conf.d and list all the files here, you will see I have a .conf file here. So nginx is going to look for nested configuration inside this file. Let's view the content of this file. So let me print the content of default.conf. Now if you look at this configuration, it basically tells nginx to serve index.html or index.htm file from this location if the server is hit on port 80. Now let's go ahead and view the content of index.html or index.htm, whatever is present at this location, user share nginx html. So let me clear the screen and go inside this directory. So I cleared the screen. I'll go to user share nginx html. Now I'll list all the files and folders present in this directory. You can see we have index.html. Here it could be index.htm also. But since we have index.html, according to our nginx configuration, this file will be served. Now let's view the content of index.html. So I'll print the content of the file using cat command. If you look closely, you will find that this is the exact HTML page that is served when you hit port 80 of this container. So let me show you again. When I say curl localhost 80, it's serving the same page. It starts with HTML and here you say body HTML. Thank you for using nginx. If I scroll up, you can see it starts with doctype HTML and here you have thank you for using nginx, ends with body HTML. Now our goal is to make nginx serve a custom HTML page that we want and not this default HTML page. So let's see how we can do that. But before that, let me clean up. So I'll exit out of this container, clear the screen, list all the running containers, stop this container using docker stop command and grab the ID and paste it over here, docker stop container ID, and then finally I'll remove this container and then I'll also remove the image nginx latest. Now I do not have any running containers and I do not have any images present. So let's see how we can customize our nginx image to serve an HTML file that we want. So the first step is going to be creating HTML file that we want to be served by nginx. So here I have a very simple HTML file that I have created which says hello from nginx container. So let me grab this file. It should be index.html, the name, right? Because that's what was present inside user share nginx html. So I'll create a file called index.html and then I'll paste the content that I copied. I'll save this file. Now the next step is going to be creating the Docker file. Now you know that Docker file is the template from which we create the Docker images. So we have to create a Docker file. So let's start with creating a Docker file. So I'll name this file as Docker file. You must name your Docker file this Docker file. Now, whenever you create a Docker file or when you want to create a Docker image, you have to start with a base image. So here our base image is going to be nginx and we'll pick the latest version of nginx. If you do not provide latest, it will automatically consider the latest image. But let me explicitly mention the latest tag here. And now the next step is going to be replacing the HTML file that is present inside this image with our own index.html file that we created. Alright, so the next command will be copy my index.html file which is present in the current directory. And where do I copy the HTML file that I created? It should go in user share nginx html, right? Because inside that image, inside this image, this is the location where default index.html file is present, right? So I am replacing that index.html file with my own index.html file. And now here finally I also have to provide what would be the final name of the copied file. So I'll keep the file name as index.html itself. So the idea is the HTML file or index.html file here will be replaced by my own index.html file. That's all. That's all we have to do to customize our own Nginx image to serve the index.html file that we created. Moving on, the next step is to build the image. To build the image from your Docker file, you can run the command docker build -t. -t is the flag that you will use to provide a tag to your image. So the syntax is going to be docker build -t. The name of the image, you can give whatever name you want, and then the tag, and then finally the path to your Docker file. So let's go ahead and build an image from this Docker file. So I'll open the terminal. So I'll go to the directory where we have created our Docker file, which is under documents, EKS course tutorials. Let me clear. If you see, I have Docker file and index.html. So I'll run the command docker build -t, and let's say I want to name my image my Nginx image. All right. And then I'll give this a tag of v1, and finally the location where my Docker file is present. So Docker file is present in current working directory. So I'll provide dot, and I'll hit enter. You'll see the image is being built. So we have two steps in our Docker file. You can see we have two steps, from and then finally a copy. So here you can see the first step is from and the second step is copy. So you can see the build details over here, and our image is built. Let's verify. I'll clear the screen. I'll run the command docker images. You can see this is the image that I created with a v1 tag. Next, let's create a container from this image and test it locally. To create an image, we can use docker run command. So let's run a container from this image. So I'll run the command docker run. I'll run the container in detached mode, and I'll give a name to this container. So I can give it a flag name. I'll say my Nginx container. I'll also do a port mapping so that we can access this application from our host machine. So I'll map port 8080 of my host to port 80 of the container. And finally, I have to provide the image from which I want to run the container. So which is this one, my Nginx image v1, my Nginx image v1, and I'll hit enter. You can see the container is running. This is the ID of the container. Let's list all the running containers. So I'll run the command docker ps. You can see my Nginx container with this ID is running. It's been up for 9 seconds, and port 8080 is mapped on the host machine. Now let's test this container. To test this container, we can start a shell session inside this container and then access the local host endpoint. So let's do that. So I'll run the command docker exec -it and then name or ID of the container. Let me provide the ID of the container, and then finally bash. I want to start a bash terminal. I'll hit enter. We are inside this container now. Let me clear the screen. Now if I hit localhost on port 80, you will see this is the HTML file that we created, right? This is the HTML file that we provided. Let's also look at the content now. So if you go to user share Nginx HTML and list all the files here. Now here we have index.html, but this is not the default index.html. This is the index.html that we created. Let's see the content of this index.html. You will see this is the one that we provided, this one. Next, let's see how you can see the logs for this container. So I'll exit out of this container and clear the screen. Now to view the logs of this container, you can first let me grab the container ID. This is the container ID. Now to view the logs of the container, you can use the command docker logs -f and then container ID or container name, and I'll hit enter. You can see the logs are being tailed. Now because I have done a port mapping, you can see the port 80 of the container is mapped to port 8080 of the host. So if I open my browser, and here if I go and hit localhost port 8080, it says hello from Nginx container. You can see this is the log. The status is 200 and you can see the system is Macintosh, Intel, macOS. Let's say if I open another terminal and run curl localhost 8080, you can see another log is printed. Alright, so in this video you learned how to create a customized version of Nginx image. In the next video I'll show you how you can create a Docker image for your Node.js and Express application. Let's clean up. So I'll close this terminal, I'll list all the running containers and I'll stop this container, and I'll also remove this container, and finally I'll remove all the images. So I'll run the command docker rmi, name of the image and tag of the image. The image is deleted. You can verify by running docker images command. I don't have any images present now. Alright, that's all for this video. I'll see you in the next one. In this lesson, we'll create a Docker image for a Node.js and Express application, and finally run a container from that image. So let's do that. In the first step, we'll create application using Node.js and Express framework. So here I have a server.js file, which is nothing but a very simple Node.js application created using Express framework. This application has 3 endpoints. The first endpoint is a root endpoint, which returns a JSON data with HTTP status code 200, and this is the data that it will return. The first field is a host field, which is nothing but the host name of the server where this Node.js application will be running. And then the second field is version, which is a hard-coded string v1. Then we have second endpoint, which is /health. It returns a very simple string healthy with HTTP status code 200. And then the third endpoint is /random, which returns a randomly generated number between 1 and 10, and then returns that number as a string with HTTP status code 200. And then finally we have the logic to start Node.js server on the port that we provide. So here this port is taken from the environment variable that we supply. But if you do not provide this environment variable, it will start the server on port 5000. Now, before we create a Docker image for this application, let's test this application locally. Now, as you can see, this Node.js application needs Express as a dependency. So we have to install this package first. So I'll create a file called package.json. Package.json is a manifest file for Node.js projects. It contains metadata, dependencies, scripts, and configuration details, which are essential for managing Node.js projects. So I'll initialize this file and then install Express. But before you can install Express using npm, you first need to install Node.js and npm. But when you install Node.js, you automatically get npm as well. So let me verify if I have Node.js and npm installed. So I'll run the command node ---- version. So I already have Node.js 20 installed, and then I also have npm. You can see I have node and npm installed. Now we can safely go ahead and install Express. To install Express, I can run the command npm install express. Now when I run this command, you will notice that it will automatically populate package.json with the version it installed. So I'll run the command and you can see it will install the package, and it will also update package.json with the version of Express that it installed. Now you will also notice that it created a file called package log.json. It's an auto-generated file that logs the exact version of dependencies and sub-dependencies. So here you can see we have Express as the only dependency, and these are sub-dependencies. These are sub-dependencies, and here the version of sub-dependency is logged. So next time when you send this file to someone, so when you send all these 3 files to someone, and when they run npm install on their system, it will look for package.json and packagelog.json, and it will install the exact version of dependencies and sub-dependencies. So that's what these 2 files are for. And then you also have a node modules folder created. Here you will see you have all the external libraries that were installed. So here you can see you have Express. All right. So Express is there, and then all other folders are the sub dependencies of Express. So that's what node modules folder is for. So let's say someone already sent you package.json and package.log.json, right? And let's say I do not have node modules folder. Let me delete node modules folder. Now, if I just run the command npm install here, what it will do is I'm not providing any specific package here. So what it's going to do is it will look for all the dependencies defined in package.json and all the sub dependencies defined in package.log.json, and it will install all the packages and libraries. So if I just run npm install, you will see it will create a node modules folder again, and it will have express and all the sub dependencies that are defined in package.log.json. Now that we have all the dependencies and sub dependencies installed, we can run this application now. So to run this application, I'll just run the command node and then our entry point server.js. You can name this file anything. It can be app.js, index.js, or whatever you prefer. So in my case, I have named it as server.js. So if I run this command node server.js, you see server is running on port 5000. Now where is this log coming from? This part. So when you run this command node server.js, this part of the code is executed and node will start a server on the port that we have provided. Since we did not provide any specific port, it will consider 5000 port and it will start a server on port 5000, and this is the log it will print. We have the node server running. Now let's test the endpoints. So I'll run curl localhost 5000 and I'll hit the root endpoint first. Here you can see it returns a JSON data with two fields, host and version. Now why host is macbook.local? Because you can see this is my host, macbook.local. That's why it's returning macbook.local. I can also open a browser and run the command here, localhost 5000. This is the root endpoint and it returns the JSON data with two fields, host and version. Now here if I hit the endpoint health, it will return healthy because this is my endpoint which returns healthy. And then we also have the random endpoint. So if I hit random endpoint, it will return a randomly generated number between 1 and 10. If I refresh this page, you will see it will generate a different random number. Let me hit it a couple of more times and you can see each time it generates a different random number. I can also let's say I can run the command here, localhost 5000 random, and let me print the status code also. So I'll run this command in verbose mode. Here you can see it returned a random number 4 and the HTTP status code is 200. Okay. Alright, so now we have tested our Node.js application. In the next step, let's go ahead and create a Docker image for this application and then finally run a container from that. Now to create a Docker image, first we need to create a Docker file. So let's create a Docker file. First we have to pick a base image. So we are going to pick a base image that has node and npm already in it because we need a node and npm, right? So I'll pick a image which is node 20. So this image node 20 has node and npm both already installed. Next we'll define a working directory. So I'll just write a comment here, working directory. Now working directory is something where all the commands will be executed. So let's say when you copy something and you do not provide the exact path where the files will be copied, in that case it will copy all the files in current working directory. So here let me define a working directory using the command work dir, and then I'll define the working directory as user src app. Next we'll copy the package.json and package.log.json because these are the files where all the required dependencies are defined. So I'll run the command copy package star.json. So I can also have two different copy command, but I can just do copy package star.json and it will copy both the files in current working directory, which is user src app. Next I'll install all the packages. So to run any command inside your container, you can use the run command. So here I'll use run, and then finally the command I want to execute, which is going to be npm install. So when Docker executes this step, it will look for the files package.json and package.log.json, and it will install all the packages defined in those files. Next, we have to copy server.js because that's the entry point file. So here again, I'll use a copy command. So I'll copy server.js in the current working directory. And then let me expose the port 5000. Now this command expose, this is only for documentation purpose. It does not do anything. It does not open any port on this container. So because I know that my server is running on port 5000, so I'm just writing it here for documentation purpose. So when someone looks at this Docker file, they know that this container will have an open port on 5000. Means that the container is running on port 5000. So I'm just writing this for documentation purposes and nothing else. And finally, when you run a container from this image, what command will it execute? It will execute node server.js. server.js. So this is the entry point command. So this command basically instructs Docker container to execute this command when it starts up. Now that we have the Docker file ready, let's go ahead and create an image from this Docker file. So I'll open the terminal, and here I have Docker file, package.json, package.log.json, and server.js. You can actually go ahead and delete this one. We don't need this one because this was just for local development. Now to create an image from this Docker file, I'll run the command docker build -t. I'll name this image my node express image, and then finally the tag I want. So let me give it a tag of v1, and then the path to my Docker file, which is the current working directory. And when I execute this command, it will start building the image. So here you can see it executed all the 5 steps. So the first step is from Docker. Alright, so it will pull the Node.js 20. And then the second step is creating a working directory. So it will create these folders if it's not present. The third step is copying all the package and package.log.json files. And finally, it executes npm install, and then server.js is copied. Now this is not a command. These two are not command, and that's why you see only 5 steps. 1, 2, 3, 4, 5. This is for documentation purpose, and this will be executed only when you run a container from this image. And that's why you see only 5 steps here. So the image is built. Let's verify. So if I run the command docker images, you will see I have this image created with a tag of v1. Next, let's create a container from this image. To create a container from this image, we can run the docker run command. So the command is docker run. I'll run this container in detached mode, and then I'll also give this container a name. Let's say my Node.js express container. And then I'll also do a port mapping. So I'll map port 6000 of my host to port 5000 of the container. And then finally, I have to provide the image from which I want to run the container. So in this case, it's going to be my Node Express image. And then the tag will be v1. So if I run this command, it will create a container. This is the container ID. Let's verify. So I'll run the command docker ps to list all the running containers. And here, this is the container be5. This is the container that was created. And here you can see port 5000 of the container is mapped to port 6000 of the host. So here, this is my host machine. I can run the command curl localhost, and here I'll hit the port 6000. And then if I run this command, you can see it returns a JSON data with host and version. Because if you look at the code server.js, you will see this is the root endpoint. It returns a JSON data, and this is your JSON data. It returns host, which is os.hostname, and a hard-coded version, which is v1. Now, why does it return host this? Because this is the container ID. So container ID will be your host. So if I actually go inside this container and run host name, it will return this. Now, if I hit curl localhost 6000 on /health endpoint, it will return healthy. when you hit health endpoint, it will just send you healthy with a HTTP status code of 200. And then if I hit localhost 6000 on random endpoint, it will return a randomly generated number. So it returned 10. If I hit again, it will return a different random number. Now let's see how you can view the logs of this container. So let me grab the container ID. I'll clear the screen, and to view the logs of this container, I can run the command docker logs -f and then the container ID. Now let me open another terminal. So if I hit the endpoint random curl localhost 6000 random, you can see it generated the log, and here the random number is returned. If I hit localhost 6000 on health endpoint, it will not generate any log, because in the logic under health, it just returns the data. It does not print anything. Same goes for the root endpoint. It just returns the data. It does not print anything. Only for the random endpoint, it returns the random number that it generated, and it logs that number that it generated. So in this video, you learned how you can create a Docker image for your Node.js and Express application and run a container from that. In the next video, I'll show you how you can push your image to Docker Hub. So let's clean up. So I'll list all the running containers. I'll stop this container, docker stop, and then the container ID. And then when this container is stopped, I'll also remove this container. The container is stopped, I'll remove this container. And finally, I'll also clean up all the images. So I'll run the command docker rmi, name of the image, and then the tag of the image. The image is deleted. Now if I run the command docker ps -a, I don't have any containers, and then I also don't have any images. That's all for this video. I'll see you in the next one. Hi, welcome back. In this lesson, I'll show you how you can push a Docker image to Docker Hub. To share your image with your team or the public, you can store it in a Docker registry first and then share it with anyone you want to. Docker Hub, as we discussed earlier, serves as a registry that enables you to either privately share your images with your team members or make them publicly available so that anyone can download your image and run a container from that image. Let's see how you can do that. But first, let's create a Docker image that we want to push to Docker Hub. So I already have this Node Express application that we created in our previous lesson. I'll create a Docker image for this app, and then later on I'll push it to Docker Hub. I'm already in the directory where I have Docker file and all the required files, packagelog.json, package.json, and server.js. So let's run the docker build command to create image for this application. So I'll run the command docker build -t, and then I'll give a name to this image. Let's say my Node Express image, and then I'll give it a tag of v1, and finally we have to provide the location of Docker file, which is the current working directory. So when I run this command, it will start building the image. The image is created. Let's verify. So if I run the command docker images, you will see I have an image, my Node Express image, with a tag of v1. Now the goal is to push this image to Docker Hub. Now before you can push this image to Docker Hub, you first need to have an account on Docker Hub. So let's go to hub.docker.com, and then you can sign up and create a user account. I already have an account, so I'll sign in. Alright, I have logged into my Docker Hub account. You can see this is my username. Now you need to create a Docker repository where you can store your image. Docker repository is very similar to a GitHub repository. In a GitHub repository, you store your code versions in different branches, right? Similarly, in a Docker repository, you store your different versions of images as tags. For example, you can see I have created a Docker repository called NodeApp. Here, I have stored my image versions as tags. So I have a version called probes, another version called delayed, liveness, v1, and buggy. So let's go ahead and create a Docker repository to store the image that we created, this image. Okay, to store this image, we are going to create a Docker repository. So I'll click on create a repository, and I'll give this repository a name. Let's say my Node Express repo, and then I'll give it a description. I'll say my Node Express application. Now for visibility, I'll let it be public because I want to share it with public. If you want this image to be a private and not share it with anyone, you can choose to keep it as private. But remember that with a free Docker Hub account, you can have only one private repositories. But throughout this course, we are going to work with a public repository. So I'll go ahead and create a public repository. So I'll click on create. The name of the repository is my Node Express repo, and this is my username. Now that we have the Docker repository created, let's go ahead and push our image to Docker repository. Now, before you can push this image to Docker repository, this image name has to follow a particular format. So the name of image should be your username / repository name. So what we have to do is, first we'll tag this image that follows this format, and then finally we can push the image. So let's do that. So to tag an image so that it follows a particular format, we can run the command docker tag, and what image I want to re-tag, I want to tag this image. So I'll provide the name of the image and the version that I want to tag. And finally, what is going to be the final tag, which will be my username, Docker Hub username, which is Reyansh Kharga / repository name. What is my repository name? My Node Express repo. So let me copy this and come back to terminal, and I'll paste this. And finally, the version that I want. Here you can have any version that you want, but I'll keep the version same as this one. Alright, which is v1. And if I run this command, it will tag this image. Now if I run the command docker images, you can see I have the image that follows a particular naming, which is username / repo name, and it has a tag. Now remember that both the original image and the newly tagged image reference the same underlying layers, and they share the same image ID. So it's not a copy of this image, alright? It's just that it created a reference to the layers of the image. So these two are essentially same. We have created this just to be able to push it to Docker Hub. That's it, nothing else. Now that we have the image tagged, we can finally push this image to Docker Hub. Now before you can push this image to Docker Hub, first we have to log into Docker Hub using command line. So I'll run the command docker login. Once you are authenticated via command line, then you can push this image to Docker Hub. So it says waiting for authentication in the browser. So I'll hit enter and it will open authentication page in browser. I just have to confirm, and that's it. I'll be logged in. Here you can see it says login succeeded. Now I'm logged into Docker Hub. Now finally I'll be able to push this image to Docker Hub. So let's do that. To push this image to Docker Hub, you can run this command docker push, and finally the name of your image, which is this one. And finally the tag v1, and that's it. So what Docker Hub will do is it will look at this image name, and it knows that it has to push to this account which I'm already authenticated to, and then this is going to be the repository where it will push this image, and the tag of the image will be v1. So let me run this command and it will start pushing this image to Docker Hub. So here you can see the push refers to repository docker.io, my username, and then the repository name, and it's pushing all the image layers. Alright, the image is pushed. Let's verify. So I'll go to Docker Hub, and here if I refresh this page, you can see this is the image that I just pushed with a version of v1. The tag is v1. Now because this image is public, anyone can download this image and run a container from that. So let's see how you can do that. So let's say I'm not logged into my Docker Hub account. So I'll just log out from this terminal, and I'll also remove all the images that I have present locally. So let me remove these images. So I'll run the command docker rmi, and then the name of the image and tag of the image. And finally, I'll also remove another image, which is this one. And the tag is v1. Now I do not have any images present on my local machine, and also have logged out from Docker. Now let's see how you can pull this image from Docker Hub. So I'll run the command docker pull, and then image name. Image name is going to be this one. And finally the tag, which is v1. So if I run this command now, you will see it will start downloading the image. So it started pulling the image from this user account and this repository, and that the tag will be v1. Here you can see the status, downloaded newer image for Reyansh Kharga, and then the repository name, and then the tag. Now if I clear my screen and list all the images, you can see this is the image that was just downloaded. Alright, So in this video, you learned how to push a Docker image to Docker Hub and make it publicly available so that anyone can download this image and run a container from this image. Alright, that's all for this video. I'll see you in the next one.